So we'll look at each of these separately. This next part of this unit is really practicing your fraction skills. So, and one of the key strategies in the next part, we're going to be doing something called trigonometric identities. And one of the big strategies for solving these will be working with fractions and doing exactly this. Can you write something as a single fraction in a simplified form? So how do we add fractions? You need to get a common denominator. What's the common denominator between b and c? Well, this one's missing a c, and this one's missing a b. So if you multiply by c over c and b over b, we get a common denominator of bc. How do we add fractions after we get a common denominator? We just keep the denominator the same, add the top. So what am I going to get on the top? I'm going to get ac plus b squared. And this is considered simplified because now it's a single fraction, whereas before we were adding two fractions. For the second one. Wow, that's a box, not a camera. There's my camera. So for the second one, we have a fraction divided by a fraction. What fraction rule do we know when we're dividing two fractions? Multiply by the reciprocal. So we'd still have a over b, but if we're dividing by c over d, that's like multiplying by d over c. How do you multiply fractions? Multiply across the top, so it'll be AD, multiply across the bottom, BC. So sometimes we have our fraction rules and we know what to do. If they're numbers, what we're really testing now is if you had anything, could you add fractions? Any variables, any functions, can you still apply your fraction rules and work with those? The third one. This third one is already a single fraction. Oh, is it frozen? Nope, there we go. Third one's already a single fraction, so as far as adding or subtracting, we're fine there. The next thing we have to check, can we simplify? And for simplifying, we check, is there anything we can factor? So looking at the top of my fraction, is there anything I could factor there? Yeah, there's a common factor of a. So if I take that out, I get a times a minus b. On the bottom, notice that the bottom is a difference of squares. So a difference of squares can be factored as b plus a, b minus a. Now at this point, we can only simplify a fraction if our factors are identical. And at this point, can you notice that none of the factors are identical yet? But this, you might remember seeing this before. What do you do if you have a binomial where one is a minus b and the other is b minus a? What could you do to make those the same? Well, if you factored out a negative 1, so I'll do that out of the top one. If I factor out a negative out of here, can you see that the a would become negative and the b would become positive? If I took a negative 1 out of the a, I'll get negative a. If I take a negative 1 out of a negative b, I'll get positive b. And negative a plus b is the same as b minus a. Can you see that by taking that negative out, I now have two factors that are identical? And so now we still have a single fraction, but our fraction is simplified because we were able to factor and cancel out a factor. Finally, our last one here. Wait for it. Prod it. Uh-oh. There we go. Here we have a fractions inside of fractions, And the skill that I want you to develop here is, can you get a single fraction in your numerator when you have fractions inside of fractions, and a single fraction in your denominator? Because if you have a single fraction on the top and a single fraction on the bottom, then you can multiply by the reciprocal. So on the top, how do I get a single fraction if I want to add a over c plus 1 over b? I'm going to need to get a common denominator. So on the top, to get a common denominator, this one needs to be multiplied by b and b. This one needs to be multiplied by c and c. If I want to add the fractions on the bottom, can you see that a single b is like b over 1? And if I wanted to add those fractions, I need a common denominator as well. The common denominator between 1 and a would just be a. So this one's missing an a and an a. When I have fractions inside of fractions and I'm showing my work, I like to keep my middle line bigger or longer than the rest of my lines. So now that I have a common factor or a common denominator on the top, it's going to be over BC. Adding the top, I'm going to have AB plus C over BC. So notice how my top fraction, I made the line a little bit shorter than my main fraction line, just so that I could keep track. That's my fraction on top. On the bottom, I'm going to have a common denominator of a, and I'm going to have AB plus C all over a. So I've succeeded in getting one fraction on top and one fraction on the bottom. And now rules are fraction divided by fraction can multiply by the reciprocal. Now, before you go too fast and say, well, how do I multiply fractions? I multiply on the top, and actually, we're not going to do this, but if you multiply it on the top, you'd have to distribute, right? And if you multiply it on the bottom, you'd have to distribute. I don't want to go too quick and just do a rule like that, because I might have something in common here that I could cancel out. Can you see that you have an AB plus C and an AB plus C? And those factors are identical. So may as well simplify them first. So you're going to always want to check to see if you can simplify things. And we get our final answer is A over BC. Single fraction, simplified, nothing you can factor. And so these skills of simplifying fractions are going to come up a lot. But instead of variables, like we did right here, you're going to use sine, cos, tan, secant, cosecant, cotangent, and working with functions. But those functions will work the same way that the variables do, and the same rules that you use for numbers work for variables, work for functions.